In Malaysia, stroke is the second leading cause of death according to the Malaysia National Burden of Disease Study. Stroke can be defined as a brain damage due to the disruption in the brain artery. Generally, there are two types of strokes known as ischemic stroke and hemorrhagic stroke. Ischemic stroke occurs by the blockage of microembolus such as plaque, blood clot, gases, and other foreign materials in the blood vessel. Meanwhile, hemorrhagic stroke occurs when the weakened or diseased blood vessel is ruptured. Both conditions can lead to the severe malfunction of the brain. According to the literature, 80% cases of stroke is caused by the microembolus.
Stroke is a disease that affects the arteries that leads to and within the brain itself. A stroke occurs when the blood vessels that carries the oxygen and the nutrients to the brain gets blocked or it ruptures itself. In our brain, we have circle of Willis. It contains a lot of blood vessels such as intracranial cerebral artery, middle cerebral artery, posterior cerebral artery, and etc.
The microembolus is also known as high-intensity transient signal or HITS. This diagnosis is done manually by human expert using the transcranial Doppler ultrasound or TCD. The HITS observation requires the human expert to remain steady over a period of time. In the ultrasound result, microembolus event can be seen through sonogram and observed through the audible sound of chirp, moan, or click. This is the risk factor that causes blockage in the blood vessel. Since there are many arteries that involve in the human brain, the occurrence of microembolus can happen at different branches of arteries. The different arteries will produce different sound, thus different threshold is needed to be set manually to adjust the variation. With the current system, while the experienced specialist is needed, the manual system seems to lead to human fatigue and error prone. Furthermore, different branches of arteries require different processing, thus it may give burden to the system.
If a new system has the ability to analyze which artery has been blocked, this would help us in deciding the proper treatment for the patients. The medication can be prescribed or the clot can either be surgically removed before the damage is done. Thus, early detection of the microemboli proves to be very good and detrimental in preserving good health of a patient.
So in this project, we address the challenges of signal variation by employing strong ischemic stroke detector and monitor. In this system, the machine learning process are involved to automatically detect microembolus from unrestricted topology area. Our inventions are beneficial for automatic detection and aid monitoring. Instead of its capability to process signal in online and offline system, it has high sensitivity and need less human expert. The non-invasive procedure is easy to be applied for installation as it can be fused to the TCD devices. The most important advantage is that it can minimize human expert effort. So next, we will present our result by using our system. So the result of the hit segmentation using our algorithm is shown in the last figure where all hits are successfully segmented. By obtaining this result, it can assist human experts to detect embolus from unrestricted topology area and assess the specific artery for each patient. This may also help the medical doctor to monitor the progress of the ischemic stroke. The doctor can assist the specific treatment based on the location of the arteries block and the severity by measuring the frequency of the occurrence.
In my opinion, this new system has the potential to help us in early detection of stroke because in current practice, we solely rely on the CT brain and MRI to do the imaging to detect stroke because our hospital are not really prepared with the CT and MRI, so this will provide another alternative for the doctors to detect stroke.
This project is also partnership with the University Science Malaysia and Hospital Tunku Nur Zahirah Terengganu for the future collaboration towards the implementation. So that's all for my video and I hope you enjoy. Thank you.